Hello you guys, welcome back to my channel. So in this video, we are going to talking about the PID Tuner in the Matlab Simulink environments. So first of all, we will also look at the definition of a PID Tuner, how to use it, and we will also guide you how to use it in a Matlab and Simulink environment. So let's get started, and don't forget to like and share and subscribe to my channel to see and learn more about the videos, and most importantly for free about the power electric and motor drive in this channel. So let's see what is the introduction of the PID tuner. So the first one, the PID tuner is provides first a fast and widely applicable of a single loop PID tuning controller for the Simulink PID controller blocks. So with this method, you can easily turn PID controllers parameters to achieve a robust design with design response time. And there are three typical design workflow with the PID tuner involved in the following tasks. So let's see what it is. The first one is launch the PID tuner, of course. So we need to run the PID tuners. You open the PID controller, and after that we click on the PID tuner, and then when launching, the software automatically computes a linear plan model from the Simulink model and design an initial controller. So this is the first one. So let's see what step choose is the step choose is the turn the controller in the PID tuner by the manually adjusting the design critical in the two design mode. So the tuner computes PID parameters that robustly stabilize the system. And then the next step is the export parameter of the design controllers back to the PID controller block and verify the control parameters and the performance in Simulink. So okay, this is the three steps you need to turn the PID parameters. So let's see one example from Matlab Simulink. So this is the system, and we look through the design overview of this system. So in this example, you need to design a PID controller for sure in an engine speed controller. And the goal of this design is to check the reference signal from a Simulink step block, speed reference, and we have the design requirement and the setting time under 5 seconds is the first one, and the second one is zero steady state error to the step reference input. So okay, let's open Matlab Simulink and turn the PID parameter. So let's see how to use the PID tuners on the Simulink storage. So let's open one example from the Mathworks. So you can open this example by typing in the command window this command, the open system SCD speed controls the PID blocks, and then we have the model here. So let's see what is the overview of this model. So we have the several blocks. The first one is vehicle dynamics, and the second one is combustion here, and we have the induction to power stroke delays. We will give the air charge for the combustion. And then we have the throttle and the manifold. And then speed here is measured, and we have the speed reference. We give to the PIs and the controls to give a command for the throttle angle. So let's open the PID controller here and to it to find the proper parameters. So the first one, we not yet have the proper PCNI parameter here. So what you need to do is click on the turn button here. And after that, the PID controllers tuners is appears. So here you can see the system already. So when the PID is tuner loss, the system already computes for the one redesigned plan model seen by the controller. So then we have a response time, sliders response time, and the chance of behavior here, and the parameter with the PNI controller here. So basically we can show the parameter with the PNI here approach 0.007, and we have the race time is about 0.3 second, and the settling time is 0.88 second. So basically this parameter we can we can approve the settling under the 5 second already, but we have a little bit overshoot 2%. So if you don't want to have the overshoot, you can increase the response time here, and let's see. So I increase the response time. The current is 0.4, so I increase a little bit, 0.6, a little bit higher to 1.8. But we have the settling time here, and overshoot we have 8%. So I reduce a little bit transient behavior. Let's see how the signal perform. So I turn it a little bit higher. Okay, so we setting time already inside 5 seconds, but we don't have the P here, so I don't want to do it. I have a little bit P here. So here's our symptoms, so I want to a little bit higher here, for example. So okay, the symptom is show parameters with the overshoot is almost 0%. Okay, so pitch is 1, and we have settling time is 3 seconds. Pretty good. Okay, so we have the overshoot is 0.6%. So it's okay, And then we will update the block here. And we already have the PNIs, so you can click the OK button and run again the simulation to see the engine speed performance. So finally we have the speed response, which is a good response, a little bit big here is about the we have a big cut 2.046, and we have the delta is the 7 second. So the symptom is very good response, and then you can see, and then you can change the parameter also. Okay, so that's all for today. I hope you guys enjoy this video and can implement it, the PID controller by yourself. Thank you very much for watching, and I'll see you in the next video. Goodbye.